Like A, B, or C.
Okay, so we're going to be looking at two different types of graphs today. The first one is called a growth function. This means as I plug in x values increasingly large, my graph is growing or going up. So as I plug in more values to the right here, I get larger and larger y values. On the opposite end of that, we have a decay graph, which is the exact opposite. It means the larger x values I plug in, the smaller y values, where it gets smaller the farther I move to the right. There's a certain thing in our function that tells us whether we're going to have a growth function or a decay function, and that is the base that we are taking to an exponent. So if we have a growth function, that means I'm taking a whole number b to our exponent x. If I have a decay function, my base is a fraction. So if I have a whole number base, it's a growth function. If I have a fractional base, it is a decay function. Whenever we are plugging in x values to try to find what our graph looks like, we always start with 0, 1, and -1. These are the three special numbers that are associated with exponential functions, just like 0, 1, and 4 are our radical x's. So let's do an example and you'll see what I mean. 0, 1, and -1. I'll write those down. So our first example is asking us to graph x equals y equals 2 to the x. Looking at this right now, I know it's going to be a growth function because the base that I'm taking to an exponent is 2, and 2 is a whole number. So I expect that this one is going to grow as I put in values to the right. Just like when we were doing radicals, 0, 1, and -1 are our base x's, but they can change depending on what's happening in our function. So the first thing we check is we make sure nothing is grouped with our x. If it is, we need to set what x is grouped with equal to 0, 1, and -1 to get our new x values. If there's nothing there, we just use those three. Is there anything grouped with my x here? Technically, but the x is still by itself because it's the only thing in the exponent. There could be like an x plus 4 or an x plus or minus something. It could also be multiplication, yes. Just not right now. So the x is by itself, which means when I make my xy table, I'm just using 0, 1, and -1 to graph this. So what I do is I take these values and I plug them in for x. This is going to be a little bit different because these values are my exponent values here. So when I plug 0 in, I get 2 to the 0 power, and what does that equal? No. 2. 1. Anything to the 0 power equals 1. So you're going to have to remember those exponent rules that we have. If not, you can plug it into your calculator and still get the answer as well. No, it wasn't, but okay. So if I plug 1 in, I get 2 to the 1 power. What does that equal? 2. Anything to the 1 power is just itself. Here's the tricky one. What happens if I take 2 and raise it to the -1 power? What happens anytime I have a negative exponent? By moving it across the fraction bar. So this becomes 1 over 2 to the +1, which is just 1 over 2. So a negative exponent moves to the opposite side of the fraction and becomes positive, and then we can simplify from there. When we are graphing, we like to have 4 points. Since I know this is a growth function, I'm going to pick another positive number greater than 1. If you only have 3, we don't get a very accurate representation of what our graph actually looks like. So let's pick another number that's close to 1, but a little bit bigger than it. 2, awesome, it's a great one to pick. You must have 4 in order to get full points. So I do the same thing I did before. I'm going to take 2. I'm going to put it up in the exponent. What's 2 squared? 4. Now I have my 4 points, and I can graph it. The first one I plugged in was 0. When I plugged in 0, I got 1. So my first point is 0, 1, which is on the y-axis. When I plugged in 1, I got 2. So I go to 1, 2, and I put my point. The third one I plugged in was negative 1. When I plugged it in, I got 1/2. So I go to negative 1, 1/2. And then the last one I plugged in was 2, and I got 4 as an answer, so I go ahead and graph it. Once I have my 4 points, I can draw my curve. And just as I expected, this was a growth because it got larger the farther right I went. Questions, concerns, or issues so far? Who thinks this is absolutely terrible? Who thinks this might not be that bad? Okay, it's not that much different than your radical graphs. Actually, I think this process is pretty much the same for them both. I know graphing is our favorite, which is why I'm trying to take it slow. Yes? You'll see when you see the homework. Yeah. You'll see when you see the homework. That is a little bit of an issue. Okay, next example we're going to do. Y equals 1/2 to the x power. Before I even graph this, what kind of graph am I going to get here? A decay, because my base is a fraction, not a whole number. So I automatically know that when I graph it, I should get really big y values on the left and really small y values on the right. Let's see if that matches. Is there anything grouped with my x? No. So what 3 x values do I start with? 0, 1, and negative 1. Since this is a decay function, I know I'm going to need another x value. Am I going to choose a positive 1 or a negative 1? I know this is a decay graph, which means it's larger on the left. So am I going to use a negative number and plug it in as an additional point, or a positive number?
Negative.
A negative, because I want to know how it's growing or where the higher points are. So what's another negative number I could plug in here? Negative 2, that's a good one. Be careful you don't pick one that's too far away from 0, because if you plug in like negative 5, there's no guarantee it's going to fit on your graph. So we like to stay pretty close to home here. Yeah, it's very similar to parabolas, yes. Okay, so then just like before, we're going to go ahead and plug these values in for the exponent and simplify it out. So I'm going to start with 0. I take 1/2 and I raise it to the 0 power, and what's that going to equal? Everybody. 1. Thank you. Make sure you have that in your brain somewhere.
My brain is full because you stopped for a minute.
No, I just wanted somebody other than you to answer. I take 1 and plug it into the exponent, and I get 1/2 to the 1 power. What does that equal? 1/2. Just whatever our base is. What happens when I plug negative 1 in? Oh. Okay, so I have 1/2, so that entire fraction raised to the negative 1 power. What happens when I have a fraction raised to a negative? What happens to that fraction? It flips completely over, and then we raise it to that positive exponent. So then this becomes 2 over 1 to the positive 1 power, which is just 2. And then we do the same thing with -2. I take 1/2, I raise it to the -2 power. Again, what happens when I raise a fraction to a negative exponent? Flip it over and raise it to the positive version of that. So this becomes 2/1 to the +2 power, which becomes 2 squared over 1 squared, which is just 4. I have my 4 points. Now I can graph them. So when I plugged in 0, I got 1. When I plugged in 1, I got 1/2. When I plugged in -1, I got 2. And when I plugged in -2, I got 4. Once we have our points, we can draw our curve. And as expected, this was a decay curve. How do we feel so far? Is anybody super duper confused? I don't think it gets much harder, like it definitely gets a tiny bit more complex, but yeah, it is. It's kind of weird. This is literally my life fiber. You know that, right?
Yeah. Decay makes me think of like a dead cell.
Science, it's already done.
You're breaking my heart exponentially. Okay, are we ready for another example? Rayleigh, I'm going to call on you for this one.
Sweet. We'll figure out how much I know. Not much.
Nothing negative.
There's a lot about not this.
Okay, so this one is y equals the base 1/2 raised to the x minus 2 power. Hold on. Bailey,
That's my name.
what am I going to do? What's the first thing I acknowledge here?
It's x minus 2. Top x.
Right, so what does that mean since I have something grouped with my x? What did we do when we had it in radicals?
Got it by itself.
Got a what?
By itself or something?
Kind of. I have to take that and set it equal to something. What am I going to set it equal to?
0. Oh, yeah, 0.
0 and what are the other numbers we use for exponential functions? And? Fantastic. Maybe you should write that down so you remember it in the future.
Probably.
So I'm going to take that exponent and I'm going to set it equal to the 3 values that I have been using. I'm going to need a 4th value, however. Do I want to use another negative number or another positive number as my 4th value?
Negative.
Why do you say negative, Ebony?
Because it's a decaying graph and you need to have a higher y.
Perfect. So what negative value should we use, hon?
-2 again?
Perfect. I like it. So we're going to take our exponent, x minus 2, and set it equal to all 4 of those x values that I know I'm going to be plugging in. And then I solve for x, and it gives me the new values that I'm going to use. So I get 2, 3, 1, and 0 as the x values that I will be plugging in to this function. So let's set up our table. I'm just going to go in order. And we're going to start plugging them in. So when I plug 2 in, I get 1/2 to the 2 minus 2 power, What's 2 minus 2? 0. So this becomes 1/2 to the 0 power, which equals what? 1. We do the same thing with the 3. 1/2 to the 3 minus 2 power. 3 minus 2 is 1. So I get 1/2 to the 1 power, and what does that equal, ladies? What's 1/2 to the 1? 1/2. And we keep doing this with the 4 x's that I have. When I go ahead and plug in 1 for x, I get 1/2 to the 1 minus 2. 1 minus 2 is -1. What's 1/2 to the -1 going to equal? 2, because I flip the fraction over and take it to the +1, which just equals 2. I get to do the same thing with 0. And it does end up equaling 4. I'm going to pause here and let you guys really take a look at all of the work on how we plugged in the x's and simplified them out to their respective y's. So take a look at that for a minute, and then we will graph this. How do you not like it? Come on. We're just going to do,
One more.
I was thinking 2. We'll do 2 more. And then we will finish it up tomorrow.
Can we start the homework or do you not?
No, you can absolutely start homework. Just after we finish the lesson.
Yeah.
Yeah, I got you.
Ariana, are we all good with this? Does it make sense? Awesome. Before we graph this, gentlemen, I would like a 1 to 5 on how we feel with it so far. So 1, no idea what's happening. 5, you could show somebody else how to do it.
I'll give it.
How are we all feeling with this?
Let's go 375.
Madison, Kaylee, Ebony, honey, how are we feeling with this? I know, I can tell.
I'm having a hard time with making a 75.
Okay, so let's go ahead and graph this, and we will do our last 2 examples. First one I plugged in was 2. When I plugged in 2, I got 1. Next one I plugged in was 3. When I plugged in 3, I got 1/2. Next one I plugged in was 1. When I plugged in 1, I got 2. And then when I plugged in 0, I got 4. We graph it, and we draw our curve. How do we feel so far? Still good? Anybody who did their graph before we did we get it right? Okay, so we're gonna do 2 more, and then I will let you be finished for the day. I make no promises. Okay, so on this one, I have the function y equals 3 to the x minus 1. Again, it is very important to note the different levels that my numbers are at. So even though I have a -1 at the end, that -1 is not in the exponent, so it is not considered as grouped with my x. It is at the end, so it's not something I had to take into account when deciding my x's. Is there anything grouped in with my x? No. If it helps you to see this, you can put your x in parentheses. That way we can tell it's separated. If you don't want to, that's fine, as long as you can tell. Since there's nothing grouped with my x, what can I use as my x values? 0, 1, -1 are my starters. And then is this a growth or a decay function? Growth, so what additional x value am I going to use? 2, 4. I wouldn't use 4, it's gonna grow very, very fast, but that's entirely your choice. I'm gonna use 2 because it's really, really close to home, but it's still another positive number. We wanted positive because it's growth, and I like to see how it's growing, so I get a very approximate graph. And then from here, we just go ahead and plug these in. I start with 0. I'm gonna get 3 to the 0 minus 1. What does 3 to the 0 equal? 1. So now I have 1 minus 1, which equals 0. So 0, 0 will be my first point. Make sure you take this in steps. This ensures that you make the fewest mistakes possible. Okay, if you try to do this all at once, you're more likely to make a mistake. We go ahead and plug in 1 next. I get 3 to the 1 minus 1. What's 3 to the 1? 3. And then minus 1 equals 2. And I keep doing this. My next one is 3 to the negative 1. Kaylee, what do I do with 3 to the negative 1? Because I can't really compute with a negative exponent, right? So how do I turn that exponent into a positive number?
We put it like over each other.
So we put it to the opposite side of the fraction, right?
Yeah.
Right now that 3 is in the numerator, so the opposite side of the fraction would be the denominator. So this becomes 1 over 3 to the positive 1 minus 1, which is just 1/3 minus 1, which equals negative 2/3. And then we do the same thing with our 2. I'm going to do 3 to the 2 power minus 1. 3 squared I know is 9 minus 1. So I actually have some fairly large y values compared to what I've had before, but that doesn't mean anything. They're still going to graph the exact same. So that's what I'm going to go ahead and do, is put this all down and draw my curve. And then we just started putting our points down. First one was 0, 0. Then we had 1, 2. Negative 1, negative 2/3. So that's going to be between 0 and negative 1. And then 2, 8. Use for what? Yeah, it was a very bad idea. But you got what? 81 minus 1 was 80. You should have, because 3 to the 4th is an 81. Once we have our curve, we go ahead and draw it. Make sure you put an arrow on both sides, indicating that this does continue on indefinitely in both directions, because it is an infinite graph. Questions, concerns, or issues thus far? Okay, I'm actually going to go ahead and stop here, because I think you guys have done a really good job. And I want to give you guys a chance to look at the homework before we get into maybe some of the examples for tomorrow. Okay? So the rest of class is homework time.
I hate